Want to nail engineering manager interviews at MAANG and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into MAANG. You could be next. To learn more, register for our free webinar.
I am expecting an interview, yes. And it's on focus on sorting, yes. So my situation is that I do have a Meta interview coming up, and it is a production engineering. So they still do the same thing as the software engineering technical screens, but I think their questions may be focusing on sorting instead of, maybe graphs, trees, and all the others.
Interesting. Okay.
So I want to focus on this topic and practice it a little more.
Okay. What's the level I should be gauging for? Whether it be entry level, mid level, or senior?
I have over 10 years of experience. I've worked for smaller companies and smaller startups as well. But overall, I have worked from languages such as Java, and then right now I am more fluent in JavaScript.
Yeah. So. All right, here already in the codebook, I see you chose JavaScript. Is that correct?
Yes.
So the problem that we were working through is called custom sort string. And we'll be given 2 input strings. One will just be called input and one will be called order. And we want to generate 1 output string. So for imagine we have an input that's sort of like ABCD, very simply. An order string that says that, hey, we want the order to be CBA. What should we expect the output to be? Well, the output would then be O. Well, the input string sorted according to the order string. So CBA, and then D is not specified, so we put it at the end. CBAD, just like that.
So to understand, start from what I would think is from very raw brute force way, I guess you can say that, not necessarily, if I would go into any loops yet, but in terms of just kind of the raw thinking. So let's say if I have input is A, B, C, D, but I'm supposed to search for the order. Let's say if I say order starts with C, so I'm supposed to search the string based on the order, which is C. So I would say, so in some ways, I would think of search on every letter. So based on the order. So let's say, if I go through the loops, so now going into a very simplistic looping. So what I would do is write a for loop and say, based on CBA, C, and then I'll search for input if there's a C. If there is, then I'll add it to the output. And then I'll go into B. Then I'll search B in input. If there's a B, I'll put it in the output. And then continue that way. So I would do that first. How does that sound? Am I on the right track?
So just kind of break down the what exactly you're doing with the input order string first.
Sure. So what I'm thinking is I would go loop through order. So the first one would be C.
Mm-hmm.
Then I'll loop through and I'll search input. And search input, I'll go through A, B, C, D. And I would found C. Then I would say I found one, then I'll add it to output.
Okay.
So at this time, I would have C. Repeat, then the next one, I would have B. Repeat this one, I would have found B. And then repeat this one, I would have found B, but then I'll add it to the array output. Then I'll have CB.
Okay.
Similarly, going through CBA. And then I would have found A.
Okay.
And then I would have CBA at this time. And I would say that's it for me at the loop. But then I'll still have remaining. Then I'll just append to here for the remaining.
Okay. So yeah, that is something that could work. There's some questions to ask regarding, what if there are multiple sort of instances of things that are not in order string?
Multiple instances that are not in order string. So you're saying input has extra stuff or order
Yeah,
has extra stuff?
input.
So
Either.
So I'm not sure. Could you maybe elaborate on that?
Well, maybe you can come up with different input cases for that.
Okay.
That might explore that a bit more.
Sure. Let's say special characters, you mean? Maybe like something like that, and then space. So here I probably don't want all those noise. So I could say if I encounter something that is not in order, so I would say if the character that I see in input does not equal to the character that I'm looping through, let's say C, let's say something valid, then so it depends on your case.
So let's real quick, let's just set that the characters will all be lowercase alphabetical characters.
Input then will be
Yeah,
A.
both input and order will only consist of lowercase alphabet characters.
Alphanumeric or just alpha?
Alphabetic.
Okay.
Yeah.
So
yeah.
it will be
Lowercase. Yeah.
Okay. And
both input or order. Yeah.
And then order would also be A to Z.
Yes.
Okay. So are you saying, let's say if I have A, B, Z, and then I would have, let's say simplistically, let's not have duplicates in the order. I don't think order is more like, order.
Yeah. So order should not have duplicates. Correct.
So then you would say, oh, I found A. I put it in my output. So here, search and add it to the output. I could say this is a set versus an array, a regular array. So a set would give you unique. So, depends on what you want me to do. Do you want me to have duplicates in the output, or do you want me to just have the one that you found? Let's say if I only have A, then my output would be, based on the order, it would be then, there's no C, but I'll just add C, right? Because you want the extra to be in the output. So,
The output, it only consists of what's in the order in the input string. The output
oh,
only
okay.
consists of what's in the input string.
Okay, sure. Then in that case, the output would be, I thought you have CBAD here. D is not in the order, but you
It's in the input string. It's in the input string.
right. So you do want stuff in the input stream, even though it's not in the order.
Yeah, so we specified that.
Okay, sure.
The output string should be the same collection of letters in the input string, just sorted.
Sure. Okay, if I understand you correctly, is that if you have extra stuff that is more than order, you want to add it. You want to add it to the output, right?
I mean, yeah, because it's still the input string. Yeah.
Okay, so I think that would still work. And then if you have, let's say A, B, B, you have duplicates in the input, and then you have the order still CBA. In that case, because there's no C, then there's nothing. So you just have the conditional statement where it is not, when you search for the input, if found, you add it. If not found, then you drop it. I guess you can just break from the either from the loop, you just go to the next one in terms of input when I'm going through the loop of the input. And then again, if now I found B, I would put B, and I would imagine you don't want extra B stuff in there, so I would use set.
Why?
Well, I mean,
Again, the same characters that build up the input string should also build up the order string, the output string.
Okay, sure. In that case, then it'll just be an array rather than set, and I will found B, and the next one I will found B again. I'll just add it B, and then Z. The next one.
There's only 3 Bs.
Sure. And then when I have 3 Bs, now it's A. Now I would have A. And then there's no Z, but according to your previous one, you do want it to add it to the end of the array. It will be Z.
Yeah, the ones that are not specified can just go at the end, but we'd still want kind of the alike characters to be grouped together.
Okay, yeah. So does this output look right to you based on this input?
Yes, based on the input, yes.
Okay. So I can walk this through again, loop through the order first. So I'm looping through the order, which is right here. C, B, and A. Well, but I'll do the C first. So when I loop through C, I would search the input, which is now A, B, Z right here. I'll search through this string right here. And then I would say not found rather than found. So I would say if not found, go to the next one. So if I have a loop here, when I do search, first of all, I think there are different ways of doing search. So I could, the brute force way is probably another for loop. And so I would say, so let's say right now we're just using brute force. So another for loop, and I am just going through here. I search, and I found, I did not found anything. I did not found C. If not found C, I would just go to the next character. So right here, if I say A, that's not C. Oh, okay, yeah. So this is very brute force. So I am doing almost I'm looping through this multiple times. So this time complexity would be a little bit larger than perhaps, let's say if we do, maybe we do pre-sort and then do a, for search, we have different algorithms. For search, we have, after pre-sort, we might be able to do binary search. No, I don't want to do that complicated, I think. I could probably do, there's probably, because there are duplicates, I might not be able to do 2-point pass. I don't know if you can do, I think you can only do 2-pointer pass for non-duplicates, but I'm not sure about that. So we, and then, or, you know, we could probably think about doing extra space, putting the array in a hash map sort of thing. And then, but then that doesn't give you the order. So I could, if I do hash map, then I would have, so I don't know about that. So pre-sort, what else do I have? If I sorted,
Yeah, so what are our main limitations here that we're trying to address?
I think before I go into that, yeah, I should check with you. Sorry, what is your question?
Well, I guess so we have this kind of brute force approach, right? That we're saying is going to have, like, we look through each thing, we're going to go through the same string, potentially, 26 different times, right? And we want to optimize that, right? So what part of that are we trying to optimize?
We try to optimize the search part. We are searching for the right, I guess, we'll go through this array and say, yeah. So we're going through this array and say, is there a, and there's an A, we'll put an A. Oh, actually for the, for loop, I'm going through, say, is this A? And I'll compare with C and say, this is not C, blah, 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 there's no C. Let's go through B, and I found B. And next one, I found B, so there's 3 Bs.
Well, could we actually do anything about, like, just looking, if we're going to look through the string for a certain character, it's, the input itself is not necessarily sorted. It's not really there's not much we can do.
So maybe
to speed that up.
Maybe I should just type it out, and maybe that would be more clear. Do you think, or no?
I mean, I understand what you're trying to do. Okay. I'm just trying to figure out. Sure. I'm just trying to figure out, like, what time win is this giving us?
So outer for loop will be looping through order. Let's say that is size of order size is equal to m, and then input size is equal to n. So I am thinking of, I'm saying m, so looping through m, I'll say C, and then I'm looping through, so it's almost m times n. And if there's the same size, it will be, if they're the same sizes, the same size, there would be quadratic n square. If there are this, if n is equal to n. So I think that's right. So let's say m, and I'm looping through here. Yeah, so that's right. So m, so let's say I am looping through CBA. I'm saying C, And then I have to say, is A C, is it A C, C, there's no C. So I'm looping through this N time, N, so it's 1M, and then B, I'm saying, is this B? No. And then this, I got 3 B's, and then put it in the output. So that's another M. And then here's C, here's A, and then I'm saying looping through this whole thing, and that would be another M. So it's 3 times M, which is N times M, which is this right here.
All right. And I guess what part of that are we happy with the solution? Do we feel like we can do better than this? What part of
Yeah,
this?
so I'm thinking, initially I'm thinking if these are all unique and I can just do search, which means, let's say if this is not, if this, there's no duplicates and then I only have A, B, Z, then I could say, you know, I could say, I would do search instead of just linear scan versus linear scan, which means I have to go through every one of them. So search, it's
What does having this search mean? Because like the fact
sure.
of the matter is, like, you know, we could very well have, like, it's not always going to be clean like this, right? You could have like A's here, and it's still going to want to sort this. So
Correct.
I'm not sure how we would get to condense this neatly.
Oh no, I'm not condensing. Okay. Let me see. This is actually, sorry. I'm not condensing. What I meant is if all input, and this is not the case, I'm just saying that the reason I am comparing these two methods is that if input are unique and I only have unique characters, then I can do search. But I'm actually doing linear scan. So like you said, I am not doing, I'm not doing, because I'm not doing search, I'm doing linear scan. So I was just thinking that initially I was thinking, how can I optimize the solution? So I was using the word search, but I realized that at this time I don't think I can do linear, I can do search. I can at this time, because there are duplicates. So my brain is going as we talk. So I'm just trying to figure it out if there's a optimal way to do this without compromise, you know, what we have here.
So rather than, so the thing is, like, trying to figure out what is the main thing that is contributing most to the time being high. And I don't think necessarily it's as we go through the string and we look for one character and try to find that character. The main issue is that we're going through this entire string many times, right? So rather than focusing on as we're going through it, you know, looking for one particular thing and finding that faster, what we should really worry about is, okay, how can I reduce the amount of times I potentially have to go through this entire string, right? So rather than going through the string, you know, 26 times or so, can I go through it once and potentially remember something about the characters I come across so that I can more easily figure out what goes in the output string?
Correct. No, thank you for pointing that out. I think that is what the main point is, that now that I'm not able to do that search in terms of reducing from from that. So I could probably I'm thinking I could probably put the input string in a hash map.
Okay, and what are the keys and values of that?
So key and value would it be, I would have A, and then I would have the frequency of A. And now that I say, oh, is there an A? Then I would have almost log of 1. I mean, time complexity of 1 constant time to get the answer of whether or not there is a. And then I could say, oh, how many A? I said, then I'll say I have 3A, 4A in this case. Then I'll put 4 A's. Then I'll put 4 A's in the output. So with that being said, to put everything input in the hash map, that would take log of size of input. And then loop through. So that would be, then I can probably reduce to a m times n. Well, actually, yeah. So m times n. So it will be a maximum, I guess. No, minimum. Yeah. Anyway, so that would probably be good. I guess that's the best I can do.
Okay. Yeah, I agree. And so how does this input hash map deal with the characters that are not in the order string?
So the characters are not in the order string. So, okay. So let's say the algorithm would still be for loop, looping through I from 0 in 0 to, I guess, order. That's, and then once we're in this loop, we would then, provided that hash map is already created with input. Well, actually, no. Oh yeah, this is order map with input. In terms of hash map character and frequency. And then once we are in this loop, so we would say, okay, if hash map has this character. Okay, if found, then append to output. Oh, if found, and then check frequency, and then append to output many times of frequency. If else, if not found, if else, then if not found, if it's not in the hash map, actually, we'll just break. We'll just be breaking because we don't need anything. That's it. Oh, actually, let's do continue because we want to go to the next character. So we are actually continuing to the next character. There's nothing to be done here. And for actually, I think for the ones that left over, that is not in the ones left over in the hash map that has not been touched. Good question. How do we mark it as it's being already it's being marked?
So they're going to be in the input hash map, right?
Yes.
But then it's just a matter of like, have we outputted them or not?
Right. So based on this, it's not being output and still left. It's still kind of like in the hash map, and we don't know which one they are unless we mark it in the hash map. And the hash map and said we have done. If we have, so we could probably, once we get this, it found, and once we put it in the when the output, we would say kind of like right here, and we would just mark it in terms of set the hash map to like let's say I found it and then I found it and I'll set it to infinity, something like that. And then the leftover would be the ones that has not, it's not infinity. So I would have to go through a quick.
Why do you set it to infinity?
So let's say I found A. Let's say I found C. In my array here, let's say I found A. Let's say this one is found. Let's say I'm going through here, and my order I am looping through. I'm finished with, let's say, C, B, A. I'm at A. So I found A, and I would set the character, which is order of I, and this is A. I would set its frequency to infinity. And so this way I'm marking it that A, so let's say hash map has, I have A in this output, in this input here, I have A equals to 4, and I have B equals to 3, and I have Z equals to 1, 2, 3, 4. I have 4 here. And then so now when I set it to infinity, I would say, oh, I founded A. I founded A because I'm going through CBA in my order, and there's no C. I continue to the next one. B, I found B. Okay, now I am infinity. Okay, so now I found, now I'm at A, and I said, oh, A, okay, now I'm going to set this infinity. My leftover will be Z, because there's no Z in the order. So I know that by the time I finish this loop, I have my hash map that has leftover of Z. So I need to add that to my output. That's my method.
Okay. Yeah, let's give that a shot. Let's have me have a look.
Okay. So function customer sorting sort. So now I would have a input in order. And then let's put it in the map first. Let's put input. And then we will have, and we would have input, we would put the, if A is not equal to defined, meaning that it's empty, then I would add frequency h map, put I would increment the frequency, then else I would put a 1 there. So that's my map. And then for I'll look through the order. I'll look through the order, check if my order, my map has that. Okay, so map. Okay, so map order is equal to map order. I have map, I have order. Oh, I might have to look through my keys. Keys and values here, because I still have to check the val key against the order. Oh, wait, no, I don't need to. Okay. So here, let's say I have map order is greater than, if it's not undefined, and it is greater than or equal to 1, then I found it. So, oops. Okay, I think if non-defined and I found it is more than 1, when I found it, what do I do? Check the frequency. So depends on the frequency. Let number of times just J. J is less than map or the frequency and j plus plus less than or equal to. Then add result dot push map. Same thing, order I times. So how many times I have it in there, I will push it how many times. So here I would have constant result equal to an array. So push it there. If not found, oh, I'll set it to infinity. Set hash map to infinity. Set it to infinity. Else, if not found, continue. Okay. After I finish that, then I would have this map to worry about. So I would have to loop through here, which is let I is equal to 0. Actually, let key in object hash map dot in hash map, key in hash map, key, okay, key in hash map. And then if hash map key is not equal to infinity, then I want to push it to the result of hash map. No, I want to push it to key. The key would be this. Return result. Okay. So let's see if that works. Console that log. Test. Custom sort input. Let's try a small one. Try this one. Input and then order is a string too. I'm not sure if I treat it as a string. I may have treated it as an array. Okay. Unexpected token. Let's see. Expected token is for I is hash map order. Let's 0 J oh, extra. Okay, console the log syntax after the argument list. Syntax error.
So you're missing a parentheses.
Yeah. ABCD. What's that? What is that? Oh, ABCD. Oh, okay, but order should be CBA. What? ABCD, CBA should be C first. So, let me see, order. So I got map. Let's see if the map. No, I think I got the map. Okay. Order. Okay, so I found the order. If this is not defined, if that I see more than one. So, so here I should have found. Here I should have found here council.log. Here I should have map order I. It should be C here. Should be C here. Map order I. Should be C. So if this is correct, it should print out at least CBA here. Oh, missing something. Okay. Okay, so it's not even going into, it's not going in here. So let me, greater than or equal to 1. So yeah, I mean, I don't need to check if it's undefined, if it's greater than or equal to 1. But if it's undefined, meaning that it's not there, it's not even there. If it's not even there, I have to check that. If let's say if your order has extra characters that input doesn't have, like if this is like, if order is like, this is ABCD and I have F here, then if it's not even in the hash map, then I have to check that. So here, if hash map, okay, so I know time is coming up. I don't know if you want me to continue or.
Yeah, I think just in the order, in the interest of time, yeah, I would definitely go through and debug this a bit more.
I think it's a small bug that I'm missing. So it's probably just the map. If it's not there, so which I've already said, if it's not, if it's in the order and it's not in a map, I have to check that.
Yeah, and I think rather than like dealing with this whole like infinity stuff, I think what you can just do is just decrement and then just remove with it's 0. And then whatever is left in the map, you can then push that.
Sure.
I think that's just a lot simpler than this like infinity and like kind of plus you can free up some space. But yeah, I think kind of just verifying whether the order is what you think it is and whatnot. Yeah, I think going through the order string the way you are, it makes sense. So, we should expect to see certain things. Just make sure that that's what's being actually pushed in that result in that way.
Got it.
But yeah, otherwise, yeah, I think the main thing is, we worked through kind of just like what the approach was, and the different approaches to go through. And I think the main thing, like, we needed to kind of streamline the thought process for like how do we get to the most kind of efficient thing. And for this sort of like a sorting problem, it's like, okay, there's ways we can go about, we can either sort this or we can do this linear scan, and we see, oh, the linear scan is actually like not too bad. It's because order is going to be capped to some constant, but then it's up to the input to be some length. So what we want to do is figure out, okay, like how do we minimize the amount of times we go through this input string? Because we know we need to go through the input string in some capacity. So how do we minimize that? Right, get our solution as close to linear as possible, and that's the sort of main thing that we need to figure out. And the thing is like, oh well, and that goes with like any sort of optimization problem, right? If you have an array and then you go through the array n times, and you have an n² solution. But maybe if there is something about the array you can kind of keep track of, with a little bit of additional space, you can kind of reduce that to one kind of go through of the array. And that's a common sort of optimization thing to kind of look for as a possibility. But in this case, yeah, we kind of get there. And then just like, I think giving us a bit more time to code that sooner than later, and then trying to at least like come up with a bit more. Doesn't have to be super long test cases, but test cases that do at least kind of like mess around with some other constraints. So in this case, coming up with like A, B, 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 Z, 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 to be honest, it's like it does deal with duplicates, but it doesn't really give you anything like new or interesting to work through unless you were to actually like intersperse them, like A, B, A, and then like a Z, and then like a an A. And like how do we deal with those situations? Oh, well, it's not like we need to sort this. What we can do is just keep track of how many there are generally, and then go for that way. Or that's the sort of like thing that I would kind of say, like make sure we kind of explore all the different possibilities that are possible, and not in a super like long or overly like time consuming way, but just like, okay, have we explored duplicates a bit more, like and the different ways that they can pop up? If so, then okay. Or have we explored like things that are in the order string or not in the input string, or things that are in the input string that are not in the order string, etc., or vice versa, right? Have we done that? If so, okay, we come up with a solution that can kind of account for all those cases, and that is this whole frequency approach. And then once you kind of have that confidence and say, okay, well, this is also as close to linear as possible, given that we need to look at the input, then let's start coding it, right? And so giving yourself kind of streamlining that, figuring out, proposing an approach, figuring out what the time complexity is, where is the part of that we can improve on, whether it be via some data structure or some other sort of thing. And then we can go into coding it. And once we're confident that, yes, this is an approach that seems to be like as close to looking at the input as we can, then we can go ahead and start coding the solution. And then just so giving yourself more time to debug this and actually get this working properly. Because I think especially for like meta, they're gonna want to see some code run if at all possible.
Yeah. Yep. That practice takes perfect, I guess. I guess if I practice this more time. So that's what this is for. I appreciate it. I do appreciate when you said, oh, this part is where it takes more time. And I think I need to focus on that. And then I thought I was very good to point that out and say, oh, it's not about search or sort, but this is the part that takes a lot of time. So what can we optimize that part? So
and that all happens in like you come up with a solution, but then you understand what the time complexity is, and okay, here's the main constraint. We're going through this n times because we're going through the string n times, and kind of going from there.
Yeah, I think it's definitely very impactful to say that, oh, this is where it takes a lot of time, and it just kind of dawned on me that's what the classes had said, and I said, oh, great, yeah, that's what I needed to say. And then what's the approach after that? Yeah,
great. Okay, well,
so just out of curiosity, is this the level of the competency level in terms of what you would give? I'm assuming you interview a lot at your company, and then this is the level where you would give it to your candidates, right?
Yeah, I would say so. There are some follow-ups that I would like to sort of I do enjoy exploring if we have the time. That's what the thing is, I'll like streamlining the time. And so like one of the follow-ups for this one would be like, what if I have a super long string, right, that is too big for one computer, right? Like how can we potentially parallelize this but still have the same output? And in that case, like what you would do is you would actually kind of split it up and then get the character frequency counts of each of the different blocks, combine all the frequency counts together, and then construct the output. So kind of like map reduce, sort of like break it up into a lot of different chunks. And so that's sort of like an extension that we don't necessarily need to code, but we can talk through once we have a solution running for the initial one. It's like, okay, well, we know we need the frequency counts. In this case, we can just calculate the frequencies independently of like a parallelized split up chunks of this super long string, and then combine all the maps together pretty quickly, and then reconstruct the output string from that map. Because all we need is the frequency count and then an order string, and we can construct any sort of like output string.
Got it. Yes. Amkar, the instructor from I did mention about map reduce on that aspect, and I need to definitely review on that. So yes, great. No, thank you. That's part 2 that you would wish to have the time for.
Yeah.
Okay. Great. Thank you very much. I appreciate it. Yeah, it's very, very helpful.
Just let me know if there's any other questions. Otherwise, best of luck.